Today's lesson, we're going to start by looking at line segments. So we're going to take a look at this graph here on line segments. So let's just look at these ones here. We have an A to B, we have a C to D, we have an E to F. All right, so if we were looking for the length of a horizontal line, the one method you can use, depending on the scale that you have on your x-axis, you can just count the units. So if we were counting A to B, that would be 1, 2, 3, 4, 5, 6. So 6 units in length. If we were looking at C to D, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 units in length for CD. And then remember, these are line segments. They don't have arrows on the end, so they're not continuing indefinitely. They have endpoints. And EF, again, you can just count your units. So 1, 2, 3, 4, 5, 6, 7. So the line segment EF has a length of 7 units. Another method you can use is by figuring out the endpoints of each line segment. All right, so for example, the line segment AB, the endpoint here, A, has coordinates of 2 and 8, and the endpoint here of B has coordinates of 8 and 8. All right, so once you have the endpoints, you can subtract the 2x coordinates to get the length of that horizontal line. All right, so if we subtracted 8 minus 2, you would get 6. Let's look at CD. The endpoint here of C, that is -3 and 4. And the endpoint for D is 7 and 4. So again, you can subtract your x coordinates. So we would subtract, you can do 7 minus -3, that gives you 10. You can also go the other, sorry, never mind. So just take the difference of the two coordinates. F and E we have next. So E, the coordinates for E would be -9, -6, and then endpoint for F is -2 and -6. So you can subtract the two x coordinates, and it still is 7 units in length. All right, so that was looking at horizontal lines. So let's say we are given a line segment AB. So it's a line segment AB, and it has endpoints A of 2, 8, and B, -5 and 8. All right, if those are the endpoints, again, what we can do is to determine the length of this line, because it's horizontal, we can subtract the two endpoints. All right, so we can subtract 2 minus -5, and we get an answer of 7. All right, so the length would be 7 units. All right, next, let's take a look at vertical lines. All right, so if you're looking at vertical lines, then you're looking at your y values because we're looking at vertical lines here. So if we look at G to H, you can again just start by counting the units. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 units in length. A length of I to J, again, you can just count 1, 2, 3, 4, 5 units. LK has 6 units. All right, but if you are given endpoints of the line segments, you can look at the difference in your y coordinates. All right, so let's just look at GH. The coordinates of G would be -3, -8, and the coordinates for H are -3 and 4. So those are the endpoints. So subtract the y values and you will get same answers. All right, so -8 minus 4, 12. You subtract your y coordinates. All right, so that is a quick lesson on looking at line segments, and we looked at horizontal and vertical lines, but that's not always the case. When you are looking at lines on a coordinate grid, they can be diagonal. So what we're going to look at next is the distance formula. All right, so the distance formula, it's actually derived from looking at the Pythagorean theorem. So let's do a quick example here. We're looking at a triangle, a right triangle, and I am just going to do a quick sketch of it. So again, this is in the modules. So we are told that this point here is point B, and it's 7, 6. And we have a point here, A, it's -5, -3. And then we're just given a point C. And we have to show that the length of AB is 15 units. So basically, show that AB is 15 units. All right, and it is a right triangle. So we can use Pythagorean theorem here to do that. So on the sketch in the modules, you can count the units down to B for A to C and B to C. And A to C is 9 units. No, sorry, A to C is 12 units, and B to C is given as 9 units. All right, so using our Pythagorean theorem for AB squared is equal to 12 squared plus 9 squared, which gives us 225. Take the square root of 225, square root of 225, and that does equal to 15. All right, so that does, we were able to show that AB is 15 units using the lengths of those two sides. All right, so using Pythagorean theorem and derive the formula of the distance formula. And the distance formula you can use to find the length of a line segment on the graph of a linear relation. And this is what the distance formula looks like. So D is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. So that's the distance formula. Put that up here. All right, so let's take a look at some examples on how to use this distance formula to find the exact length of line segments. So let's take a look at our first example here. We have point P at 2, 3, and we have going going to point Q, which is at 10, negative 3. All right, so using our distance formula, instead of using x2, x1, or y2, y1, you can use P and Q instead. So I'm just going to write that out here. So the distance of PQ is going to be xq minus x of P, and it's squared, plus yq minus y of P, and it is squared. Okay, so let's fill in our points next. So our x of Q is 10, and our x of point P is 2, so 10 minus 2, and it is squared. And then our y of Q is negative 3, and we're going to subtract it with y of P, which is positive 3, so minus 3, and that is squared. And then you have to take the square root of it. All right, so 10 minus 2, that becomes 8 squared. And then negative 3 minus 3, that becomes negative 6 squared. And don't forget, it is still all under that square root sign. All right, and then 8 squared plus 36, that we get as square root of 100. Square root of 100 is 10. All right, so therefore the distance of PQ, is equal to 10 units. All right, let's take a look at another example. We need to find the exact length of the following line segment. So we have G at negative 25, 3. And we have it going to H, which is negative 17 and negative 5. All right, so let's find the distance to GH. So I'm just going to write that out. I'm going to use x of H minus x of G, that is squared, plus y of H minus y of G squared. All right, so again, notice that if I'm using H to G, I've used x of H, x of G, and then same thing here, it's y of H and y of G, so don't mix up the second ones. If you've used H to G, then use H to G here. All right, so x of H, that's negative 17, and it's minus negative 25. All right, so minus negative 25. I'm just going to write it like that just to show you. But you could also have written it as negative 17 plus 25, because minus negative 25 would just become plus. I'm just going to write it like that for now. And then plus, we have negative 5. That's my y of H. Minus the y of G is 3. So minus 3 squared. And don't forget, all of that you do have to take the square root of. Okay, let's continue. You'd put this in your calculator. that would give you 8 squared plus -8 squared, all of that under the square root sign. All right, put that into your calculator and we get square root of 128. All right, now since this question has said to find the exact length, that means it's not asking for a decimal answer. So what we can do now is simplify this further, use a perfect square that will multiply to give me 128. So I'm going to use 64 and 2. 64 times 2 gives me 128. 64 is a perfect square. Square root of 64 is 8, so our answer is 8 root 2. And that is the distance from G to H. All right, so the next thing we're looking at here is the midpoint of a line segment. So midpoint, basically, is just the center of the line segment. So if we had a line segment like so, the midpoint would be right in the center, so that would be your midpoint. All right, so there is a formula that you can use to figure out the midpoint of a line. And the formula is, let's use an example. Let's say we have PQ. It's a line segment, and we're going to say P has the endpoints x1, comma y1, and point Q has the endpoints x2, y2. All right, so using these two endpoints, our midpoint formula looks like this. x1 plus x2 divided by 2, and y1 plus y2 divided by 2. All right, that is the formula we're going to use to get to the midpoint. All right, and we use capital M to show midpoint. All right, let's take a look at an example, and we're looking for the coordinates of the midpoint of the line segment with the following endpoints. So let's say we have P, it's at 0.47, and we have Q, and it's at 0.123. All right, and we need to find the midpoint of this line segment. So using our midpoint formula, midpoint, so it's x1 plus x2, so x1 plus x2, so 4 plus 12, divided by 2, comma, y1 plus y2, so 7 plus 3, and it's divided by 2. All right, so 4 plus 12 plus 4, or 4 plus 12, that's 16. 16 divided by 2 is 8. 7 plus 3, that's 10. 10 divided by 2, that is 5. So the midpoint of this line segment would be at the coordinates 8, 5. Okay, let's try another one. We have E at -5, 7, and we have the point F at -11, -2. All right, so x1, Write that out here. So x1 plus x2, so negative 5 plus negative 11 divided by 2, comma, y1 plus y2. So 7 plus negative 2 and divided it by 2. All right, so negative 5 plus negative 11 divided by 2, that gives me negative 8. And then 7 plus negative 2 over 2, that gives me 5 over 2, and we'll leave it as a fraction. So just 5 over 2. So that would be the midpoint of these two coordinates. All right, let's take a look at another example. Move this. Sorry, just gonna put that back. All right, so we have here point A, our x is w plus 3, the y is 2w. At point C, our x value is 5w minus 1, and our y is 7w plus 1. All right, so same formula. I'm just going to rewrite it here. So midpoint, that's x1 plus x2 divided by 2, and then y1 plus y2 divided by 2. So just rewriting that just so we have it there for reference. All right, so let's add up our x values together. So x1, that's w plus 3 plus 5w minus 1. So w plus 3 plus 5w minus 1, and it's divided by 2. And for our y values, y1 plus y2, so y1, that's 2w plus 7w plus 1. And it's divided by 2. All right, so let's collect our like terms and simplify. All right, so we have w plus 5w, that becomes 6w. And then we have 3 minus 1, that becomes 2. So we have 6w plus 2 divided by 2. Next, we have 2w plus 7w, that's going to become 9w, and plus 1, and it's divided by 2. All right, simplifying this further, so 6w divided by 2, that gives me 3w, and then 2 divided by 2, that's plus 1. And then here we can't simplify anything further, so we'll just leave that as 9w plus 1 over 2. All right, and that would be our coordinates for the midpoint of the line segment AC. All right, so next example, Ruby was doing a question in her coordinate geometry homework, and her little brother Max wrote over part of the question as a prank. So basically, she's missing this point here, and she's missing this point here. So we have to calculate the missing coordinates. All right, so let's take a look at figuring out our x value for our midpoint. That's easy enough because both of our values are showing here. So our value for x, midpoint, would be 5 minus 11, or 5 plus negative 11 divided by 2, which is negative 3. So that's our value for the x here, negative 3. We're still missing our y value here, but we do know what the midpoint value is, and we know what our second value of y is. So we can calculate that. Y of p, that's what we're missing, the y value of p. So we can calculate that. So yp minus 10 divided by 2 is equal to negative 6, right? Negative 6 is what the midpoint value is. And now we can calculate our yp, isolate yp. So the first thing I'll do is get rid of this 2 by multiplying both sides. Multiply both sides by 2. That gives me yp minus 10 is equal to negative 12. All right, and then we'll add 10 to both sides. So negative 12 plus 10, and that gives me, I'm just running out of room here, but yp is equal to negative 2. All right, so now we have figured out our value here. It's negative 2, and we figured out our midpoint of x, which was negative 3. All right, any questions? Any questions for me? All right, so 2 different formulas we've learned today. First one was distance formula. Distance formula is to figure out the distance of a line segment. And then midpoint formula is used to find the midpoint of a line segment. All right, so for homework, let me just record that because we do have some students missing. I'll just write it up here. For homework, lesson 2, under linear relations, lesson 2 goes over the distance formula, numbers 1 to 12, and then lesson 3 is the midpoint formula, 1 to 15.